Hello, voice is silent.
Okay, so yeah, so we'll start the session now. And am I audible to everyone? Is my voice clear?
Yes, sir.
Okay, so yeah, so mostly we'll be discussing all the important stuff from week 1 to 6. Okay, and then basically some of the concepts from the graph theory. Those are important for your upcoming paper that you are writing on third. On third, I guess you're writing the paper. So yeah.
No,
So
sir.
yeah. Yeah, you're asking something. So if you're not asking anything, I'll just start with this. I'll just share my screen. Just let me know whether you're able to see this or not. So I'll just wrote it some important stuff because like very difficult to cover all the stuff of week 1 to 6. That's why I just wrote it some important stuff that I'll be discussing here. And mostly those are important for your paper also that you are going to write it. Okay. So I'll just discuss the important stuffs that I feel for your paper. Okay. And maybe the next lecture we'll be discussing the remaining portion. Okay. So I'll just start with the week 1. So how many of you have seen the lectures? Have you went through the lectures, all the content, or you didn't went through the content?
We were not able to finish it, sir. Personally, I did week 1 to week 3.
What?
Yeah,
What?
yeah, lots of lectures we need to go through. So slowly going through one by one.
Okay, got it. So,
Sir, it was like 186 lectures, so I went through like 100 of lectures. Uh, After 100, it's remaining. Sir, I have one doubt also. Will you be discuss sample paper, like if we have any doubts in sample paper, will you be discuss here?
not now, but okay. So you can just mail me regarding that, the doubts. But now I have been just told to just discuss all the important concept of from week 1 to 6. Okay. I'll be discussing some problem that I will tell you that this type of papers, this type of problem you can expect in the exams. Okay. Have you solved any graded or practice? You didn't, or did you?
Sir, I have
Yes.
solved the questions which were there in the lectures, and I tried to solve that sample question, but I have some doubts in sample question. I will mail you that. Sir, can you share your mail ID?
Yeah. I'll share my mail ID in the end. Okay. Or maybe you can write it
Okay,
down. Vishal@study.iitm.ac.in. Okay.
okay. Thank you, sir.
Huh. So, okay. So I'll just discuss the important thing that you should be focusing more, and I'll discuss some of the important questions also. So that similar problem or on the similar concept, you can be expected some problems. Okay. Yeah. So we'll start with the basic thing that the set, and you already are aware of what is set, and also set is basically a collection of well-defined item, and you can have a two types of set, that one can be finite and one can be infinite. So the infinite will be having a that you can't like for example, a set of even numbers. I have written all the stuff, so set of even numbers. So it will start something with, if you are taking 0 as an even number, or if you are not taking, then you can start with 2, 4, and then 6 to infinite. Okay. So it will be like you can't count the number. But if you have a set of natural number that is less than 10, then you can write it down, right? It will start with some, if you are taking 0 as a natural number, so 0 to 1 till 9. So, okay. And there is one convention that we are taking 0 as a natural number in every aspect. So maybe some of you would have not have read, maybe you would have read like whole number. In the whole number, generally you take 0. Okay, that's the different convention, but we are taking 0 as a natural number. So some of the author take 0 as a natural, some, so okay, it's fine. We are taking 0 as a natural number here, but that is not going to make any difference in your exams and all. Will not be having any confusion regarding that. So basically the set you can just classify as a finite and infinite sets. Okay, so in this from set, you can expect some problem similar to like the way that maybe you would have solved in class 10th or 11th, like on the simple example, like if you have common that intersection and the union that you solve, if you have like some players are playing cricket and some are football, and then what is the number that is common there? So those type of problem you can expect in the paper. Okay, and basic properties of the sets are like whatever the item, like for example, here we were having some from 0 to 9. So we have some 10 item. So that item generally we call the set as element, and there's if whether you are writing 0, 1 to 9 or 0, 9, 8, something, so that is not going to make any difference. Okay, and if you have a duplicate also, let's for example, you have a set that is consist of 0, 1, 1, that means you have just 0 and 1 as an element in that set. Okay, so order and duplicate doesn't matter in a set. And cardinality is simply the number of element that is there available in the set. Okay, so these are just the basic, but the important aspect is the subset and the proper set. Okay, so the subset is like, let's for example, you have a two different set x and y, and if x is a subset of y, then it means that every element in the x is also in the element of y. Okay, let's for example, you have x and y. So is the x subset of y? Can somebody tell me about this? If you have a subset that consists of element as A, B, C, and you have a Y that consists of A, B, C, D. So it's
Yes.
SX. Okay, it's a subset. Like you can see that A, B, C is available in Y also. Okay,
Yes.
similarly, you have a power set where the equality doesn't hold. So that's the difference between the normal and this proper subset. The proper subset will be having that equality doesn't hold. Okay, that's so is this X power set of this proper, sorry, not power set, the proper set of proper subset of Y, whatever the example that I gave you.
Yes.
Yeah, that is also available because the equality doesn't hold, but X and Y is not same, right? So that also is fine. And there is one important concept in the set theory, the how do you like if you have been the set if you have been given something like you have to write it the square of, let's for example is square of even integer. So there you come along three things. The basic thing is the generator and the filter and the transformer. In the generator is like from, let's for example, you have to know about the square of even number. So somewhere from something you'll be doing, right? Let's for example, you have some integers. Okay, let's for example, it's asking for a square of even integer. So for each integer, you'll be doing that square, right? So generator is those things from where you are taking out the number. Okay, and the filtering is like because you need the square of even number. That means the mod of that whatever the value you are taking, the mod of that value with 2 should be equals to 0. That means that divide the 2 should divide that. That is how you'll be getting the even integer. And the transform is what you want, like x square you want, right? Because you've been asked to calculate x square, right? A square of the even number. So you have been asked the transformer should be the first one that should be doing the x square. So you want whatever you want in that set, the new set that you want to make. So you want x square, but you want to have something like you have to apply some filter also, because if you are not applying the filter, it will just give you all the x square that will consist of the even number also. But you just want the odd number also. So you just want the even number. That's why the mod. And if okay, let's for example, if you have been asked to calculate square of odd integers, what would you have done there? What was your filter at that time?
Can you ask that question one more time, sir?
Okay, so here it has been asked the x square, the square of even integer, right? And then in that case, the filter is what? X mod 2 is 0. X, because you need the even integer, right? if you need the even integer, that means that number should get divided by 2, right? But if you need the square of odd integer, then which type of filter you will apply to get that
X mod
odd
2
number?
is equal
Mod
to
Mod
two
equal to
1.
1.
Yeah,
Mod
mod
2
should
not
be
equal
equal.
0.
Correct. So this is what you will be applying, and this is how generally you write that. So basically, square of integer you generally write is like this, right? So you'll be writing this transformer such that x should be belonging to what this generator should be. Okay, it's like it's not it's right. It's integer, and the filter should be at the end. So x mod 2 equals to 0. This is how generally you write. It's like pretty simple. It's not that important. Like it's not that difficult. Okay, and the most important thing is relation. So you should be expecting some question from relation, and this we'll discuss and like elaborately we'll be discussing this. Okay, so whatever we have discussed till now, the set and the basic, what are the type of set, subset, and then the set comprehension. Okay, if you should not be having any doubt in this, but yeah, the relation is like the most important thing that you should be focusing from week 1. You should be knowing each and everything about the relation, like whatever the properties that 3 or 4 that whatever we are reading, that you should be aware of that. Okay. So if you have a Cartesian product is what, like, can somebody define the Cartesian product? It's basically the ordered pair, right? If you have a two set, right? So two non-empty set, if you have like A and B, A consists of something and B consists of something. So if you are doing this Cartesian product, you'll be having one element from the A and one element from the B, right? So A will belongs to A and B will belongs to, so B is coming from B and A is coming from A. And here, as this is relation from A to B, so the relation basically from A to B will be what? Will be like the subset of this Cartesian product, that whatever you have got. So you have something like, for example, A is like A is something, for example, 1, 2, okay, and you have a B. This is A and B. So what will the Cartesian product for this? Like pretty simple, right? You'll be getting 1A and then 2A and then 1B, 2B, right? And one more thing is here the order is important. So in the set I told you the order was not important. If you are writing this, because A1, okay, this is not equals to 1A, correct? Or is it correct? Or is it same? If you're writing, okay, if you're right, like for example, A is one set and B is the another set. If you have been asked to calculate the Cartesian product of A cross B, that supposedly not be asked, but okay, I am asking you. A cross B will be what? Will be something like 1A, and then you'll be having 2A, then you'll be having 1B and 2B. Correct? If you are writing, so this is not equals to A1, right? Because one is been mapped to A. Okay, so in the relation, this order matters. Okay, so you can't be writing 1A as A1. So there, this becomes a different relation. Okay, A is related to 1, maybe 1 is related to A in some, let's for example, some X relation, and but this A is not similarly related to 1. Okay, that's the different relation itself. So that's why order matters in the relation. Relation is, if we are writing relation from A to B, is basically the subset. So this whatever you are getting will be coming from something from the Cartesian product itself. Okay, and so here I told you here order is very important. So order, if you are writing if you are jumbling the order, that means it's a different relation itself. Okay, and the basic three properties of the relation is reflexive, symmetric. What is the other one? The third one?
Transitive.
Transitive. And this is important, like you can be given some relation, okay, and then you will be asked whether which of how many of them are like transitive, how many of them are reflexive, or maybe they can ask you in the MCQ MSQ type question also. They can give you some relation 4, 5, and then can be asked like the first option can be the R1 is reflexive, R2 is like R1 is symmetric, R1 is so transitive and on, or R1, like this type of problem, or maybe 4, 5 relation they can give you, and then can be asked how many of them are transitive or how many of them are reflexive and all. Okay. So I'll tell you one statement. So whatever has been written is like very important. Reflexive relation, if you have a relation been given, and if you have to know that whether that relation is a reflexive or not, then let's for example, if you have a relation R on a set S, okay, it's the set, and if you have a relation R on this set, then if R is reflexive, if and only if for all X. So this word you should be mentioning. This word is very important for all values of X. So let's for example, if you have a set S and it consists of 4 words, like 4 element. Okay, let's for example, this is ABCD. I just wrote it down here. If you have ABCD, okay, so the reflexive, whatever that set that you are getting. So for a reflexive function, sorry, reflexive relation, all the values like AA, BB, CC, DD should be present. Then only it can be a reflexive. That's why I wrote it down. All X belongs to S, whatever the set that you were having in the starting. So all X's should be present in the R. Then only this R is a reflexive function, a reflexive relation. Otherwise, if you have just AA, BB, CC, let's for example, you have a set AA, BB, and CC, and CD. Is this relation reflexive? So I told you a statement. If and only if all X belongs to S. So S, I was having this ABCD as S. And S was a set in the starting, ABCD. And then we need to, you have been given a relation R. And then you have been asked whether R is a reflexive relation or not. Is it or not? Can you tell me? Can somebody tell me about this?
No, sir, it's not reflective.
No, sir, it's not.
It's not a relation because why is it is not a reflexive relation?
DD is not there.
Yeah, so this is what I was telling you. This word is very important for all the values. You can be given them 2, 3, but all the values, all the elements should be there in a form of XX. Okay, so this is what has been written. R is a reflexive relation if and only if for all X belongs to the set S, XX should be present in the R. Okay, so how many of them R1, R2, R3 is a reflexive function relation?
R2.
Okay, how many of them R2? Why not R3?
Also R3, sir.
R3 is basically you're just A, B, B, C, D, C, C, D, D, and this A, B. Okay, so basically I'll write it down. A, B, B, C, C, D, D, comma, A, B. Is this relation R3 is a transit reflexive relation or not?
No.
It is reflexive.
Just
How many of you are saying yes, or how many of you are saying no? Okay, first tell me how many of you are convinced that this is a reflexive relation.
It is reflexive.
It is reflexive, sir.
This is reflexive, right? Okay, 2 has raised their hand in support of reflexive. How many? Okay, 3, 4. Okay,
It's not
and the rest?
reflexive.
Okay, I'll ask you. Okay, so out of 26 people, 4 are saying it's a reflexive. Okay, 5. Okay, and how many of you are saying it's not a reflexive? Okay, 2 people. So how the rest one, what they are doing? Okay, so yeah, so it's a reflexive because I told you in the starting the statement, you can read it again, is a reflexive relation if and only if for all X. Okay, it's just putting a condition on X that if X is belongs to S, then XX should be present. If but for our case R3, whatever the set in the set S, so S was having 4 elements. For all the 4 elements, we can find AA, BB, CC, DD, right? AB, okay, it can be present. That is not going to make any difference. Okay, so for all the X, XX is present, right? Is it clear to everyone? So
Yes, sir.
told you for
Sir,
all
so
the
for
X belongs.
sir,
Yeah,
I have a
go
doubt
ahead.
actually. So for being reflexive, the element should not be the same. It should contain in the set only, but it's not important that both the elements like the xs, xx should not be the same.
No.
Like,
Yeah. See, if all the element, like for example, here I was having 4 element in S, right?
Yeah.
Okay, if all the 4 elements occur in pair, like the same element in the pair form, and
okay,
other than that, anything like is there in the set that is not going to make any difference. Okay.
okay.
Yeah. That's for this example R3. So that's why R2 was there. So R2 you can see that only you can see that x, like for example xx was present for all the values of x that was present in the S set. Or let's for example this is making you confusion. So let's for example this is a T. So for all the element of the set T, you have xx, right, present in the flexible relation or R2. Okay. Other than that, whatever you're getting, let's for example, you can have AB, you can have something like CD, DA, that is not going to make any difference. Okay. So this 4 should be present. If you have 5 element, then 5 elements should be present where XX should be present. Okay. Other than that, you can write it any other element is present, that is not going to make any difference. Okay.
Okay.
Okay,
Is
sir.
it clear to everyone?
Yeah.
Yeah. So let's move to the symmetric now. Symmetric relation. So and here also relation R is symmetric if and only if for here also for every value of x and y belongs to R, there should be, if yx is present, then that relation is symmetric. Okay. What did I say? If and only if this relation will be symmetric for every x and y in the relation that is present. Okay, yx should also be there. Okay, let's for example, I have a set S 1, 2, 3 is present. Okay, and R1 is a relation where 1, 2 and 2, 1 is present. Is this relation, so is this satisfying our condition, whatever we have said? If and only if for every xy. So for every xy, let's for example, in R1, what is that x for the first case? X and y is what? 1, 2. For that case, 2, 1 is present or not? Yeah. For the next case, it's asking for every value, right? This is the important, for every xy. So you checked for the first one. This is x and this is y. Is yx present? Yeah. Correct? Yx is present. Okay, the next part. For this one, let's for example, this is x and this is y. Is yx is present? Okay, 1, 2 is present. Is this a symmetric or not?
Yes, sir.
Correct?
Yes.
You understood,
No.
right? Okay, I'll give you one more relation and then tell me.
Yeah, sir, but 1, 3 and 3, 1 is not part of the set. So is this symmetric or not? Because
It's
every
symmetric. I
value
told
of-
you, see, read this statement again. R is symmetric relation if and only if for every xy belongs to R, yx is present. It's not applying any condition on our this set. Okay, so here it was applying something on our set itself. X for if and only if for all x belongs to S. Okay, so this here, for the reflexive function, it was applying some condition on S itself, that whatever the number of elements is there in S, xx should be present. But here, it's not applying any condition on S over the given set from where we are making this relation. It's just saying, if you are doing anything on the R1 relation, just check it for every xy, yx is present or not. If present, then it is a symmetric.
Yeah, got it.
Got it, right? So I'll give you one example, like one more, and then give me the answer. Like anyone can give me the answer. I'll be like 1, 2 is present, then 2, 3, then 2, 1, 3, 2, 4, 3. Okay, is this a symmetric relation?
No.
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 Why?
No, sir.
Because
4
4,
is
3
not
doesn't
there.
have 3, 4.
Because 3, 4 doesn't.
Okay, if I'll write it 3, 4, then
Yes.
Yes.
that's a
Yes.
symmetric.
No, but like you have
But
three
it is not a part of
numbers,
a
1 to
set.
3. 1 to 3 only you have in yes, like
Yes,
1,
4 is
2.
not a part of set.
4 is in part of S, right?
Where is 4 here? Okay, when 4. Okay, yeah. You're right. Okay, if I have to write it here 4,
Yeah.
then only this R1, R2 is possible. Okay, now R2 is a symmetric, right?
Yeah.
Yeah.
It's a symmetric.
Okay, if I'll write it down, R3 equals to R2 plus I'm adding one more element, 4, 4. Is this symmetric?
Yes.
Yes.
Here
Yes.
also it's symmetric because for every xy you can find a yx in the same relation, right? So this is clear. So reflexive and symmetric both are clear to everyone.
Yes.
Yes, sir.
Okay. So the next part is the transitive relation, and this is also important. See, transitive relation is here also just read it the statement itself. So R is said to be a transitive relation if and only if for every pair of element xy and yz. See, xy, yz is present, then you should be looking for xz. If that is present, then relation is transitive relation. So if you've been asked for transitive relation for each and every, so you can see that for every pair of element, you should just go and see that if xy 1 2 is present, just see that 1 2 was present. So just check for whether any element starts with 2 or not. If it starts with 2, like for example, it's 2 3, then you should be searching for 1 3. If 1 3 is present, then it's a transitive. If it's not present, then it's not. Okay, I'll give you one example. Maybe that will help you to understand. Okay. So you have an example like, for example, you have, so the same set S where 1, 2, 3, 4 is present, and you have a relation R1, 1, 2, 2, 3, 1, 3. Is it transitive?
Yes.
Yes.
Yes, sir.
You can see that.
Yes.
What did I say? For every pair of elements. So for just check for xy. Okay, this is xy. So you just check for whether any element that starts with y. So y here y is equals to 2. So okay, it starts with 2. Okay, this is yz. So check for if xy is there, yz is there, then xz should be present. Is there anything that is like 1 3 is there or not? 1 3 is there. So if 1 3 is there, that means from first case it is transitive. Now you check for the second one. So I'm just telling you, so just see this statement. So first for the every pair it's asking. So for first pair I seen. Okay. For first pair I have checked. Now you have to check for the second pair. For the second pair, it starts with this is x and this is y. Is there any element that starts with 3?
No, sir.
No. So if you don't have yz, then it's fine. There is no problem. It's just asking for every pair of xy and yz. If xy, yz is present, then xz should be present. It's not telling anything about if xy is there and then let's, for example, this is some ab and this is some different number, then it's not applying any condition. Just saying if xy present, yz is present, then xz should be present. Okay, then only it's a reflexive. Okay, and if xy is present and yz is not present, then doesn't matter. Like it's already a reflexive. Okay, is it clear to everyone?
Transitive.
For the third point itself, again you see xy is any set any like element that starts with 3? No, right? So if this is xy, I'm not able to find yz itself. Okay, for the so for every element, so for first element it was there. For second element we couldn't find yz itself. For the third element also we couldn't find yz. So it's not no any point in finding xz. So okay, so the first from the first set, it's from the first element itself it becomes a reflexive. Sorry, what was that? Transitive. Sorry. Did you get this, or should I repeat it again?
Got it, sir.
Get it?
You got it, right? Should I give you one more example? Okay,
Yes, sir.
so
Yes, sir.
that was there, and then you have been asked. So this is one relation, R2, 1, 4. Is this a transitive? Is it transitive?
No.
No.
Now just think it. Okay, what did I say? If for every element xy and yz is present, then xz will be present. For our case here, xy is present, yz is not present. So you not need to check anything else. It's a transitive.
Okay.
You got it. Xy and yz is present, then only you should be checking xz. If xy is there and yz itself is not there, then it's already a transitive. No need to worry about like anything else. Okay.
Okay.
Did you understand, everybody? Okay,
Yes.
then if understood, okay, tell me about the R3.
Not trans. Yes,
Okay.
trans.
Transitive, right? XY is there. YZ is not present. Any can you see any element that starts with 3? No. Okay. Okay, so it's gone. Now again see for this 1, 4. Is there any element that starts with 4? No. Okay, then it's transitive. See, if 3, 1 was there, okay, 1, 3 is there, 3, 1 is there, and then 1, 4. Is it transitive now? Is it transitive now? This
No.
R3?
No.
No, because you already know that for every pair of element, if x, y, y, z is present here, x, y is present, any element starts with 3. Yeah. Okay. Now I should be searching for x, z. That means 1, 1. 1, 1 is not present. Then it's not transitive. Not transitive. Okay.
Yes.
Is it clear to everyone, or should I repeat it again? And this is important. Should be knowing this.
Yes, yes, sir. But if there is 2 or 3 examples more, it will be fine.
Okay. I'll just give you one more example. So it's like we have already passed 40 minutes. So we are in the first week itself. So I'll just give you one more example. And that example is, let's for example, this is R4. 2, 4, 1, 2, 1, 4, 4, 1, 1, 1, 2, 1. Is this transitive or not?
It's not transitive, sir.
Just see it minutely. I guess you are doing some mistake. So everybody just try to solve. This is our last example for this case, and then we'll move further in the function.
It is transitive, sir.
See,
Sir, it is transitive.
for 2, 4, any element that starts with 4 here. Okay. So for you, 2, 4 is there, 4, 1 is there, then 2, 1 should be there. 2, 1 is there. Okay, fine. Next element. 1, 2 is there. Is there any element that starts with 2? Okay, this one. So 1, 2 is there, 2, 4 is there. What? So 1, 2 is there,
It is
4 is there.
transitive.
Correct. So if 1, 2 is there, 2, 4 is there, then 1, 4 is also available. Okay, so for this element also it passed. 1, 4 is there, 4, 1 is there, 1, 1 is there. Okay, pass. 4, 1 is there, 1, 1 is there, 4, 1 is there. Yeah, pass. 1, 1 is there, and then again you have 1, 4. So you can see that 1, 1 is there, 1, 4 is there. Okay, so 1, 4 is also available. So everything is available. So you can see for each pair, for xy, yz is present, all the xz pairs are present. You can check it for all the case. I have checked, right?
No, sir, only one question. X and Z can be similar also, like one. Like Y, X and Z can be similar also, similar number. X and Z.
It can be. Yeah, it can be.
Oh, oh,
The value can be same. So
same.
xy ka value can be 2 and y ka value also can be 2. Okay.
Oh, oh.
So that means what? If you have been given something like this, 1, 1, 2, 2, 3, 3, 4, 4. Is it transitive?
No.
No.
Why?
because 2, 1 could be is not available in that list, in that set.
Okay, so one more thing. See, if something is not available, okay, that's fine. See, I told you XY and YZ is present, then only you should be searching for XZ. If YZ itself is not present, then it's not going to make any difference in your answer. See, you just start with, okay, this is a transitive. And then see for XY and YZ. For each pair, XZ should be present. Then only, and if that is not present, then you should be like not transitive. If, see here, for 1, 1, is there any element that starts with 1? This itself. Okay, so 1, 1 is there. So this can be XY. And this again can be YZ. So XZ is present. Is 1, 1 present? Yeah, it's present. 1, 1.
Oh, the same element can be the other pair also.
Correct. Can be any other pair also. Okay. So I told you, let's for example, one more example, 1, 2. Is it a transitive? Is this
Yes, sir.
Yes.
is a transitive, right?
Yes.
Because
Yes.
you can't find any YZ. If you're not able to find YZ, that means what?
Yes.
We
That
don't need
means
to bother about
searching
X.
for XZ. Okay. Okay. Shall I move forward?
Yes.
Is it
Yes,
clear
sir.
to everyone? Okay. Let's move to the function now. In function, basically, it's just a relation in which each element in the X. So you have some, for example, 2 box and then X is mapping to Y. So you have a 2 set X is mapped with the element in the Y with some function. It can be some quadratic polynomial, anything. Okay, that doesn't matter. Just the function. The definition is such a relation with from one set to the other set. Okay, and in a function, it's like this is the important thing. In a function, there should not be 2 pairs with same first like element. That means for one value itself, let's for example, there's a function. Let's for example, you are just thinking that fx is a function. And if at 3 and -3, both the values are same, that means it's not a function. Okay. That means, see, if you have a box that consists of set X, this is a set Y that consists of Y. Okay. If you have something like, let's for example, you have 1, 2, 3. Okay. And here the values are A, B, C. If one is mapping to A also and one is mapping to B also, is this a function?
No,
No, sir.
no, sir.
Okay, so maybe, okay, what did I say? I guess in the starting I said something wrong about that. Okay, so from 1, so what is in the function, there should not be 2 pairs with the same first. Okay, so the first pair, one can't, so at like, for example, if you have a function, something like this is not a function, right? Because you know that at this point, at some value A, you can see the function value is 2, right? 2 function value you are getting. That's why it's not a function. Okay.
Okay.
And if you have function like this, is this a function?
Yes, sir.
Yeah, you can see that for each of the value you are getting some different, like even for, let's for example, for 3, you are getting some F3. And for some minus, okay, so this is -3 and this is 3. Okay, so you are getting some difference. So that means like at one point you should not be getting 2 values. That's the only, what you can say, excluding part. Other than that, really satisfying all the things. Okay, you'll be in the next week, you'll be seeing that you have a vertical and the horizontal test that you should be checking to check whether this function is whether whatever the given statement mapping or relation is a function or not. With you can check it with the vertical test. Okay, and then there's a horizontal test that will tell you that whether this function, whatever you are working on, is a 1, 1 or not.
Sir, I have a doubt.
Yeah, go ahead.
So, so you said order matters in Cartesian product. So in relations, does order matter? It matters, right?
Yeah, in relation it matters. This is how, let's for example, you have some relation A to B with some relation R1. Okay, this can't be same as like B to A, right? Can be with some relation R2, but it's not pakka this R1, right?
Okay.
It can be for some cases, but it's not always true. But in the set, if you have 1, 2, 3, because like collection of all the things, like let's for example the set of natural number, you can write it like 3, 2, 1 also. It's like this, not going to make any difference.
So if
But
it
in
is
a relation,
pair,
if A is related to B, that doesn't mean B is related to A. If you have a function, let's for example a quadratic equation, y equals to some x square plus 5. Okay, so that is this related, right? A at 1, this related to 1 is mapped with what? 6, correct? So x is
yes,
1, y is right. 6 and 1 is not related, right? Are you putting, if you put the value of 6 here, you'll not be getting 1, correct?
yes, sir.
Yeah.
Yes, yes.
So the order is important in relation.
So only in sets, the
Order doesn't matter.
doesn't matter. In other,
Yeah.
every pairs like x comma y, wherever it comes like x comma y,
Uh-huh.
it matters, right?
It matters, yeah.
Yes, thank you, sir.
Correct. And you have basically two types of function, that injective first and then the, like basically 3 types of function, but okay. So whenever you have the injective function is like each element in the X, whatever you were having 2 boxes, right? And if you are mapping A, like first box to the second box, if you are mapping, okay, and each element from the first box is mapped to the distinct element in the set B, like, okay, then it's an injective function. For each value, you'll be getting a unique value in the set B or set Y, whatever you want to say. So from first box to the second box, if you are mapping, you'll be getting a unique value in the set B. Okay, I'll tell you maybe in the exam, like in the week 5 again, we'll go through this injective and surjective. There I'll give you some examples also. Here, just get an idea about that. Surjective is like if the range is equals to the codomain. So codomain is like in the starting, you just define a function. Let's, for example, a function, it's such that is A related to B. It's like A mapping to B. And then A is your domain. Domain is all those values that you can put it inside your function. Okay. And B is the outcome. Okay. And range is the exact outcome that you get from the function. Okay. Let's, for example, you have some 2 box. This is A and this is set B. This is a domain. So the value that you can put it inside the function. And this is B that you can get. So the codomain. But the exact function, the range will be something, the subset of this codomain. Okay. And if a function satisfy both the condition, this is a 1, 1 and this surjective also, then you can say directly it's a bijective function also. So to check the injective function, you can have a simple idea, like you can do that horizontal test. Let's, for example, you have a function. Okay. It's a function, something like a straight line. Okay. This is a straight line, some linear function. Okay. So what you can do is you can just plot a horizontal line. If this horizontal line cuts the function at one time only, then you can say that this is a 1, 1 function. Okay. That if you have a, let's go. Okay. So is this a function 1, 1?
No, sir.
No, because it doesn't pass your horizontal test, right?
Yes.
Yeah. If you just draw a horizontal line, you can see that at 2 points it's cutting. Is x cube a 1, 1 function?
No.
Yes, sir.
So this is also passing horizontal test. There is another method that to check whether the function is a 1, 1 or not. So you can check whether the function is a strictly decreasing or strictly increasing. If a function is any of the two, you can directly say it's a 1, 1 function. Okay. So let's, for example, this linear function. So is it strictly increasing or decreasing? Can somebody tell me?
It's strictly increasing.
Why is that? Because you can see that if you are taking some 2 value x1 and y, x1 and y, x2. Let's, for example, x1 is greater than x2. If you are taking some value here, x2, and this is x1. And let's, for example, x2 is greater than x2. x2 is greater than x1. So you can see that at function at the x2, you can see that the function value will be x2, and that is greater than function at x1. That means what? That's an increasing function. If you are increasing the value of x, your y is also increasing. This is what you're strictly increasing. So there's a basic difference between strictly increasing or just a increasing function. Okay, it's like increasing if you have been, but you should not be knowing much about the difference and all, because like just to check whether the function is a 1, 1 or injective, you just should be knowing whether the function is a strictly increasing or not. It's not that increasing. Increasing can be a function such that it can be increasing for some value, for some like interval, and then it can be constant for some. So it's like constant for some values, right? And here the horizontal test will fail. Correct? So that's why it can't be a 1, 1 function or whatever the injective function that you say. Is it clear to everyone? So to check whether the function is a 1, 1, you can check with the two method, like horizontal test also you can do. Okay, if you are not knowing the function, what you can do is you can check whether this function is strictly increasing or not, or strictly decreasing. Whether it's strictly decreasing also, that is fine. Let's, for example, this is a function that is strictly decreasing. Okay, if you are increasing the value of x, the y is decreasing. Then also it's a 1, 1 function. Correct?
Yes, sir.
So is it clear to everyone? How will you check? And this is important. So you should be expecting one question from here. 1, 1, this bisective, surjective and all. Okay, you should be expecting whether the function is a 1, 1 or not. You will be given 2, 3 functions and then mark it out which of the function is a 1, 1. Okay, so just if you understood well and good, you should be practicing some questions. Okay, just go and practice. So whatever I'm saying, I'm like going through, it's all important. Okay, if you are just done this concept, whatever I'm going through from week 1 to 6 and the graph theory, if you have done this, you'll be able to solve all the questions. You'll not be missing any of the single questions. Okay, that I can say you. Okay, now we'll come to the week 2. So week 1, I told you the important portions are the relation that you should be knowing. So you'll be given the relation of like 5, 6, and then you'll be asked to how many of them are transitive, how many of them are. And one more thing, if you have okay, can somebody tell me the one term that we use if your relation, whatever the relation you have is like all the three is satisfying for reflexive, symmetric, and transitive? What do you call that?
Equivalence relation.
Yeah, so you can be asked for that also, whether this function is equivalence or not. So you should be checking for each of the 3 conditions. First check for the symmetric, then for reflexive, and then transitive. Okay. Okay, so I told you the important words also in each of the reflexive. The word was all, so you should be checking for all the x. Okay, and for that symmetric, you just see that whether if xy is present, yx should be present. X should be present. And for the transitive, if xy, yz is present, then I should be searching for xz. Present, if it's present, it's like transitive, and then you can say that it's a equivalent relation. Okay, and then the other part is the 1, 1. That will be, so that is merged of week, the function 1, 1 and all should be like mostly inclined to the week 5 content. So you'll be asked from those questions. You'll be given some 2, 3 functions, like for example, x cube or maybe some mod. Okay, can you tell me whether mod function, mod x is a 1, 1 or not? 1, 1 or not?
It's many ones, sir.
No,
it's not 1, 1, right? How will you plot this? Generally goes like this, correct? And then the horizontal test won't pass here. But if you have been given the mod x and then you have been given the domain or the interval as 0 to infinity, now is it a 1, 1 function from 0 to infinity?
Yes, sir.
Yes, sir.
Now it is, because you are now, your domain has decreased, right? So now it is from 0 to infinity only. So in this, you can see that it's simply the y equals to x line, and that is an increasing function. So it should be a 1, 1. Okay. Okay, let's move to the other part, week 2. And week 2 is pretty simple, and I'll tell you the important portion also of week 2. So week 2, this just consists of like a straight line. Okay, a straight line is what difference, like you have been given 2 points, and these are all not be asked, like not this simpler questions will be asked, like section formula. You should be knowing all these things. The formula at least, you should not be given the formula. So calculate the distance, or maybe the section formula. If you have been given 2 plot, what is the midpoint and all those things, you should be knowing. Area of triangle, you should be knowing. Okay, from the area of triangle, I'm not discussing all this because so I'll be discussing the other part, that those are more important. Okay, the area of triangle also you can be asked. Maybe 3 collinear point can be given, then asked. So what's the area of 3 collinear point? Do you know what is collinear point?
They are in the same line.
They are in the same line. So what should be the area of that?
0.
0. So yeah, so the area of a collinear, 3 collinear, 4 collinear point would be 0, right? You can be given some 3 point, and then so don't waste time on again calculating the area. So it should be first check that whether they're lying on the same line or not. Just calculate the slope of 2 point, then for the slope of the other 2, and check whether the slope are same or not. Okay, because if the slope are same, there is no possibility that the area will be able to calculate, right? Even if you have a 2 parallel line, you can't be calculating the area. It will not form any triangle, right? So mostly it will be given, if you have been given the area, many a times will be given the collinear point only, because everybody knows that it's very hard to calculate. It will, laborious process. Okay, it will take some 5 minutes to calculate the area of triangle. Okay, so first check for the collinear point, whether it's a collinear or not. If it's collinear, then just mark it as 0. Okay, and then you'll be given the straight line to the straight line, then maybe with slope or something, and then you'll ask to calculate the equation of the straight line. Okay, so can somebody tell me about the parallel, when the two straight lines are parallel? Let's, for example, you have a1x plus what, b1, and then you have, this is y1, the first straight line, and then the second one is, then what should be the value? What can be the relation between the slope if you have a two straight line?
0.
No.
0. What is that 0?
Slope should be equal, sir.
Yeah, slope should be same, and for the
Should
perpendicular
be
line,
equal.
M1, M2 equals to -1.
2 minus 1
yeah, so the product of the slope should be equals to -1.
minus
Correct.
1.
And now we come to the most important portion of the week 2. You should be knowing this one. You should be knowing how to calculate the sum of squared error.
Sir, your screen is not visible.
I think solar system has been shut
Sir
down.
is dropped out, yeah.
So I'm really sorry. I just got my laptop got switched off. Okay. So where were we? We were talking about
Of the parallel lines.
sum of a squared error, right? Okay. So we were here. Okay. So, and this is the important portion that should be knowing. Everybody should be knowing this, how to calculate this sum of squared error. Okay. Can somebody tell me what is the sum of squared error?
Sigma I is equal to 1 to n.
Okay, that is fine. Okay. The statement, can you tell me the statement? Why do we calculate this? So basically, this is the error, right? Okay. Let's, for example, you have some data given, and then you have built a model. Okay. Let's just for the sake of understanding, I'm saying you have a model. You have predicted that this x and y, whatever the data you have got, it should be following this equation. Okay, y equals to 2x plus 2. But after seeing the data, you have to calculate some error that is like how far your data is from your model. Okay, so how will you calculate that?
Substitute the x and y in the
Correct.
equation.
You should be substituting the value of x and get the y cap or whatever you want to say. So you should be getting something y. Let's, for example, if you'll put it 1 here, what will the value you'll be getting? Y for the first case, for the first data. Y cap. So if you are putting x equals to 1 here, what you will be getting? 6, right? Or what? 4, sorry. So for the first data. See, data given is the data that you have got, but this is the model that you have built. You thought that it should follow this relation or the function. This should be followed. Okay, but you have calculated, like in the class 10th or 12th, you would have done some lab, you would have calculated the error that generally you calculate. This is what the here also you are calculating the error only, but here in the different form. Here you are calculating the sum of squared error. Okay, yeah. So you just build a model. You have a model, some model M1. Okay, and that model M1 is following some relation. Okay, 2x plus 2. You thought that it should be following this. From the given data, you calculated your value. Okay, from your model. Okay, let's, for example, it's my model, and this is y equals to 2x plus 2. I thought it should be following this. I calculated y cap as for the first data it's 4. For the second data, if I'll put it 2 here, till getting 6. 4 into 2 is like 8 plus 2, 10. I got it this one. How far is this value? That you have to calculate. Okay, so this is what. So the term itself tell you sum of squared error. So you should be doing the square and then calculate the error. Okay, do the sum, do the square, then do the sum. Okay, and then calculate it. Okay, if we have been asked for, like here it's not been taught about the mean squared error, otherwise you would have done the mean of that. Here it's just the squared error, so you just be squaring the error, whatever you are getting, just square it, the difference, like 4 minus 5 ka square, and then 6 minus 6 ka square, and then 10 minus 1, 9 ka square. So you are getting something 101. So whether you are doing y1 cap minus y or y cap y minus y cap, it's like same because you are doing the square. Okay, and then this is your squared error. Okay, is this clear to everyone?
So
Yes.
formula.
Yeah, go ahead.
I haven't done. So
Yeah.
the formula is yi minus mxi minus c. Why don't we just put the example equation into the formula, and why can't we solve it like that? Why should we
You
find
do
out
that
why?
also, you'll be getting the same value.
Yes, we can use that also, right?
Yeah, you can use that also. But it's like, this is what we are doing. This is what y minus y equals to c. This is what you are doing here also. This y cap is some that random thing that you're. So this can be one equation, and this y cap can be your from the value that you're getting from the model. Okay. Or maybe this mx minus c can be your model value, and this can be your data that you're getting. Okay. So from both the cases, you'll be getting the same value.
Okay.
Sir, can you repeat the final answer of this question?
There's 2.
Okay, thank you, sir.
Okay.
So what if the data is not given?
No, data will be given. Then how will you calculate if the data is not given?
So there is a question in the mock where the data is not given, only the equation is present, and they ask the sum square error.
Okay, they would have asked something minimum or maximum, something that you have to differentiate it equal to 0.
No,
something will be
just
given. Yeah, so it should be something else. It's not that they can't ask sum of a square. There will be like some minimum or maximum square error or something will be given. Okay.
Sir, in the third
Sir,
row, 10
only
minus 9, how came 10 minus 9 square? How? I am not able to understand. 10 minus 9.
Okay, I'll give you one more example. It's okay. Just add one more thing here. I'll just delete it, and you calculate from your formula. Okay. Everybody should calculate this. I'm just adding one more point. 9:18. Use the formula, calculate the value. I'm just waiting 1 minute. I'm waiting, just calculate the value. What you'll be using, what formula you'll be using? Summation of this formula, right? What is this? Y minus, what is the value of m here? 2x1 plus 2 square. We'll be adding for 1 equals to I equals to 1 to 4, right? This is what you'll do.
Sir, it's minus 2, sir.
What minus?
2xi minus 2, sir.
This is 2x minus 2. See, this is what I did. The starting, I told you what to calculate. You have some model value and just put the value of x. So this is what it's doing. So first it's calculated the y. Or let's put this is y minus. You're from model M1, you are getting some value, right? And then you are doing the square. So yi is what? This value 5, 6, 9, 18. Okay. This is from the data. And this is from the M1 model, from my straight line. Okay, this is what I'm getting. Okay, and this I'm squaring. So the error from the model minus the data ka square. So this is what the error we are getting. So we built a model and we thought that this relation, this data, x ka data should be following this. And the y is also given. And then you have to calculate the error.
Sir, I shared the question in the chat box. Could you please see that?
Okay. So a student has, so I told you what is the best fit value. I told you then you have to just calculate something, differentiate it, equate it to 0. Let's, for example, let's take this question. Okay, tell me the equation, what has been given here.
B square minus 6B plus 9.
B square minus
6B plus 9.
Okay. So a student was calculating sum of the square root and she found that this is a function of b. And this is the value that she got. Okay, this is a function of, and this square root is a function of b square b. And what is the best fit value obtained by minimizing? So we have to minimize. Okay, if you have been given a function in some x and y, how will you minimize the value at what? Okay, let's, for example, this is in the form of x square minus 6x plus b 9. If you have a function, y is the function of x. If you have to minimize this function, what will you be doing?
2 times differentiate.
Okay, differentiate it to x minus 6. This is what the value of. Okay, let me see what is. Okay.
Or we can take the x value of the vertex, sir.
Okay, that also we can do. But it's like asking something else or what?
That would be the minimum value of the function if we substitute the text.
Wait, I'm just checking. Where did you get this problem in the
mock paper test, sir?
Okay. What will be the best fit value obtained by minimizing? Okay. Okay, if we minimize the value, we'll be getting x equals to 3. And if you are putting 3 here, what are the value that you are getting? 3 square minus 6 into 3 plus 9. What are the value you'll be getting? 9 plus 9, 0, right? Yeah. So what you have to do is like first minimize the function. So at what point it is minimizing? S equals to 3, right? Just differentiate it equate to 0. So if you have a function, any function, it's like basic, it's like quadratic equation, right? And you have been at which point your vertex is there. Like vertex is, what is the formula of vertex? Can somebody tell me? Minus b by 2 or something like that, right?
Minus b by 2.
You'll be having some value. Okay. So this is what it's been asking. Okay. So for which value? So you just have to minimize this SS. So this is what I was saying. If you have not been given some data, you should you have been already asked to minimize this function first. Okay. While minimizing, you got that at x equals to 3, you are minimizing the function. Okay. And what is the best value for at that point? So if you'll put the value at here, you'll be getting 0, right? And that 0 is that one. Okay.
Sir,
Is
I
this
have a
clear
doubt. I
Yeah.
have a doubt. Sir, according to calculus, when we differentiate any function one time, we got its maximum. So dy by dx
What?
when we differentiate any function one time, like dy by dx, we got
Okay.
maximum.
No, this is
And
not correct. This is not correct. If you are differentiating one equation, okay, so let's for example see dy by dx equals to 0, that give you any function that at that point the slope is 0. Okay, you are just equating the slope at 0 at that point. And then if the d2y by dx square is negative, then you can say that at this point the function was minima. And if this d2y by dx square is greater than 0, then you can say that at this point, okay, so this is the like, if this is greater than 0, this is minima, and if this is less than 0, this is maxima. Let's for example, this example itself. Okay, you have this function y equals to x square minus 6x plus 9. You are doing d2 dx dy by dx. What is the value you are getting? 2x minus 6 you are getting. Okay, why I am equating to 0? Because I'm hoping that like the function at that point the slope is 0. Okay, if you have some function, if you have, let's for example, this is minima and maxima, that's the other question, just let it be. And when it's a maxima, at this point the slope will be 0, right? Or this just tell you the dy by dx tell you the slope at that point. If the slope at that point is 0, because maybe it can be maxima or it can be minima, that doesn't matter, the slope will be 0, that's for sure, right?
okay.
Okay, dy by dx, see in the straight line also, what is the slope? If you have a slope, this you are generally calculating dy dx, that you get it tan theta in the form of tan theta, right? This gives you a slope, right, at that the whatever the plot you have. So this also will give you this also give, if you have a function and if you are differentiating one time, it will just give you the slope at that point. I am equating to 0. I'm hoping that at that point the function is minima or maxima. Just the I'm just hitting it down, and then if I'm getting the value, see at 3, if you will differentiate it, double differentiate it, 2 d2y by dx square, what are the value you are getting? 2, right? I told you whenever this is a positive, that means at that point you are getting a minima. This is what I told, right? d2y by dx square is greater than 0, then you'll be getting a minima at that point. And if you are getting negative, that means a maxima. Let's for example, other question, y equals to minus x minus, okay, and this is x square minus something 6x plus 9. Now you differentiate it, you'll be getting 2x plus 6 equals to 0. Okay, at x equals to 3, you'll be getting what? Maxima, right? Because here, if you'll differentiate it, double differentiate, you'll be getting minus 2, right? This is less than 0. So at x equals to 0, x equals to 3, you'll be getting maxima. And from the plot also, you can see that x equals to minus x squared plus 6x plus 9 will be something like this, right? At this point, at this vertex, you can see that this is your vertex, minus b by 2a is your vertex. And minus b by 2a, how do you get that? You generally differentiate it equated to 0. This is how you get the value of x, because we know that at this point the slope will be 0. That is how you see, let's for example, ax square base bx plus c equals to 0. Okay, you have to calculate the vertices. Okay, what you will do? You just do differentiate it, 2ax plus b equals to 0. You are getting what? X equals to minus b by 2a. Because you have equated the slope at that point equals to 0. That means at this vertices your slope is 0, right? At this point. That is how you are getting x equals to minus b by 2a. And then you are putting the y value to get the other y axis, y ka value. Is it clear to you?
Yes, sir.
Okay. So you can calculate it that way, or in the quality equation we'll see that. Okay, I just taught you here also, but okay, in the quality equation also we'll see that how do you get the vertices and all. Okay, so this problem is clear to everyone. So we'll just go, and because it's like 9:20, so we are in the second week itself. We have to study 4 more weeks the graph theory. So let's come to the third week. Okay, here your all doubts will be clear. Okay, let's for example, this is a quality equation. A is positive. Let's for example, A is positive. What should be the plot of this graph? X square plus bx plus c.
Parable.
It will be upward, right? If it's upward, then at this vertices, what should be the value should be maximum or minimum?
Minima.
Okay. Who was asking this doubt? This the differential wala doubt. Who was asking that doubt?
Sir,
So see that if you will differentiate it here also, and from this function, when a is greater than 0, you should be getting what? You should be getting minima, right? Correct?
Yes.
And you differentiate it 2x. If you will differentiate it 2x plus b, you'll be getting double differentiated. I told you now at the double differentiation, this value is what? 2a. That is positive, right? If this is a positive, then this function should be having minima at this point. Correct?
Yes.
So from double differentiation, you can get an idea, from not from the single differentiation. Okay. From the single differentiation, you can get an idea that whether this function is increasing or decreasing. That is, I guess you don't have to study that. Okay. Is it clear? Now you can see that. And how generally we get that? This slope, this is the formula for the slope at this point. And if this slope is, if you are equating to 0, because these are vertices. If you have any plot and at the vertices, the slope will be 0. That is why we are equating to 0. And if you equate it to 0, you'll be getting some value, x equals to minus b by 2a. And this is what the vertex is, right? And if you'll put the value, this minus b by 2a in this function, you'll be getting the y ka value also. And that is your other, what you can say, the y coordinate of at that point. Okay, so this is what upward parabola. What should be changed in this formula, this equation, so that this parabola will go downward?
A should be negative.
A should be less than
negative,
0.
correct? And if, yeah, so the same thing happened, right? If you have a 2a, so a is negative, that means your double differentiation is negative. That means you should be getting a maxima at that point. This is how we are doing. So here, this is a downward function, minus, this is something like a x square plus bx plus c. Here a is negative. Okay, so you are getting what? The slope is 2x plus b, a is negative. So that's why you are getting maxima at that point. So at this vertices, you'll be having a maxima value. Is this clear to everyone now?
Yes, sir.
Okay, let's move further. If you have any doubt till now, you can just ask me. I'll just wait for 1 more minute. 1 minute. I'll just have a sip of water and you can just ask your doubt. Fine.
What was the answer to the last question? Sum of square error.
Okay, the answer was, I guess, 6. The answer is 6. Okay, I didn't solve that. Okay, sorry. I'll solve it in end. Okay, I'll solve that in the end. Nobody has any doubt, huh? Or should I move? What is the answer? Okay, so the answer, I'll solve it again. I'll solve this. We'll be getting 6 as answer. Should I solve this? Or will you be able to solve this?
6 was coming.
Not coming, huh? Okay, I'll solve this.
6 is
it's coming, huh?
Yeah.
Okay, should I skip this? Okay, let's see. Y cap. This is your y cap that you are getting from this model. So y cap, what is the value that you will get? If you will put 1 here, you'll be getting 4. If you're putting 2 here, you'll be getting 6. If you're putting 4 here, you'll be getting 10. And if you're putting 9, you'll be getting 20. Okay, so what is the difference? 4 minus 5 ka whole square, 6 minus 6 ka whole square, and then 10 minus 9 ka whole square, and then you are having 20 minus 18 ka whole square. So you are getting 1, 0, 1, and then here 4. So your answer is 4 plus 1 plus 1. You are getting 6. Okay, is this clear to everyone? Should we move to the next part? Okay, if you have any doubt, you can just ask me now itself. Yeah, so this was the vertex, like from the quality equation, you'll be getting some simpler question. Should be knowing how to calculate the zeros and how should. So what is the zero of any quality equation?
It's the root of the equation.
The root, the point at which the quality equation will be equals to 0, right? Yeah, so how will you calculate that? It's a pretty simple formula, or you can do it like other method also, but this is the simplest formula that you can just remember, or you can, after solving 2-3 problems, will be having this formula in effect. Okay. Yeah, any doubt? Anybody is having any doubt till now? And if this determinant that you call is positive, that means you'll be getting 2 real roots, and if it's equals to 0, you'll be getting some repeated root. Okay, and then like 1 real root only, and then if it's less than 0, that means you'll not be getting any root. Okay, real root. You'll be getting the root, complex root, but not. And complex root you don't have to study it. Okay. Is it fine to everyone?
Yes, sir.
Yes, sir.
Yeah, just solve for me, solve this equation. 4x square plus 9x minus 9. What is the root of this equation, or the zeros, or the root, or the solution of this equation? Yeah, did you solve this? So you're getting something 3 by 4 or minus 3, right? So you can just put it on the formula and say, so quadratic equation will not be getting that difficult question from this week. Okay, let's move to the fourth, and this is an important portion, the polynomial one, and I'll tell you the type of problem that should be getting. Okay, and if you have a polynomial of some n degree, maybe mostly it will be asked for the some let's for example, and this type of problem should be expecting the exam. If you are able to understand this, you'll be able to solve the problem in the exam also. Okay, if somebody doesn't see, have not seen any of the questions also, like any problem you have not seen from the polynomial, just focus here, just 5 minutes, and you'll be able to solve the problem that will be asked in the paper. Okay, so try to, because this is the only concept that this is the most important concept that has been taught in the 4th week, polynomial, from the polynomial. Also, all the weeks will be asked like do the addition, do the subtraction. You already are aware of that. How will you add the addition? How will you do the addition? How will you do the subtraction or multiplication or division? Okay, so the only part is like how will you plot the graph, like the equation that has been told to you. Like for example, this is a plot that you have been given. Y equals to x minus 1 ka whole square, and then x minus 3, then x plus 5 ka whole square, then x plus 7 ka whole cube. What are the roots that you are getting? Can you tell me the roots of this equation? It's already written here, but okay. You are already aware. How will you get the roots? So,
By computing that equation to 0.
yeah, what are the values at which the equation will be 0? So you can see that at minus 5, this function will be 0. At minus 7, this function will be 0. At 3 also, function will be 0. And 1 also will be 0. Okay, multiplicity is simply the how many terms. Like at minus 5, you are having your root is like how many repeated root at minus 5? 2, right? And then at minus 7, you have 3. And then at 3 is like 1, and at 1. So this will help you to know the plot. Okay, this multiplicity will help you to know the behavior of a plot. Okay, and this is the most important thing that I'm telling you. The behavior, how to know the behavior of any plot. Okay, how to plot that equation or the function that has been given to you. Okay, how will you start this? Can somebody tell me how will you start if you have been given this type of equation, polynomial, or some difficult polynomial or difficult equation function to you? How will you start? How will you think of plotting that? You have a root, right? First of all, you have a root at least. At root, the value, the function value will be 0, correct? So how many times the function value will be 0? At 4 point, right? If you are from minus infinity to infinity, these are the 4 point at which the function's value will be 0. Okay, can you tell me at minus infinity for any function? I'm telling you for any function. If you have to know the behavior, just start with the minus infinity, go to the minus plus infinity. Minus, just check the value at minus infinity. What are the value that what are the y value you are like getting if you are putting x equals to minus infinity? Okay, if you will put x equals to minus infinity, what are the value you'll be getting? Can you tell me? If you put x equals to minus infinity, some bigger value that you can't imagine, what is the value that you'll be getting at y? So just put the value x equals to some large value. So you'll be getting what? Y will be what? A large value in the form of positive or some minus infinity or plus infinity will be getting?
Plus infinity.
Plus y. Because you have the whole, you just add the multiplicity. Or you can think of if you will just do the product, all the multiplication if you'll do, what are the coefficient that you'll be getting? Will it be positive or negative? You'll be getting 2 plus 1 is 3 plus 2 is 5 plus 3 is 8. Okay, so you'll be getting some x to the power 8. What are the coefficient you'll be getting? The coefficient will be positive, right? Because all the coefficient are positive. You'll be getting some coefficient, positive coefficient. Okay, so y is in the form of 8 x to the power 8. If you are putting x equals to minus infinity, you'll be getting plus infinity, right? Even if you are putting minus infinity or plus infinity, you'll be getting plus infinity value, right? Because you have x to the power 8. So it's like even power. So you'll be getting some plus infinity, correct?
Yes, sir.
Is it clear to everyone? Okay, so I'll
Yes, sir.
just so to know the behavior, what you'll be doing, just put the value at x equals to minus infinity and x equals to plus infinity. So we already know that the function is in the form of something plus x to the power 8, and this doesn't matter to us. Okay, so if you are putting plus infinity, you are getting some plus infinity as a y, and if you are putting minus infinity also, you are getting plus infinity. That means your function will start. Okay, so that I already wrote. Your function will start something from infinity and will go till positive infinity, right? If you're putting x equals to minus infinity also, will be starting with minus infinity, plus infinity, right? Okay, I'll just plot it here again. If you have this function, the function, if you are putting x, this is x, right? This is x-axis, this is y-axis. If you are putting some minus infinity, this is minus infinity here, and this is plus infinity here. Some bigger value that you can't imagine. Okay, if you're putting this minus infinity, what is the value of y you are getting? What did I say? If you have a function y equals to x to the power 8, what are the value you'll be getting? If you're putting minus infinity divided by 8, right? It will be minus infinity, right?
Plus infinity.
Minus infinity.
Sorry, it will be plus infinity, correct? So we'll be having some infinity here. Let's, for example, y infinity is here. You're getting infinity. You start with infinity, right? You'll start with infinity. Again, at positive infinity, you have positive infinity, right? You're putting as plus infinity also, you'll be getting y as plus infinity, correct?
Yes, sir.
Correct. So you'll start. So you have this, all these two value have. And now just see what are the roots. You have a root -7. So this is -7. This is -5. What are the other values that you have? 1 and 3. So you have 1, this 3. Okay, this has been denoted here also. So it's already written here. -7 you have. So it starts with minus and plus. For minus, at minus infinity, your value is infinity. At plus infinity also, your value is infinity. Now you have root as -7, -5, 1, and 3. Okay. Now check the multiplicity. Okay, so at 3, you started, okay, this is infinity. At 3, let's come to the 3. 3 is the root. At 3, just check what is the multiplicity, whether it's a even or odd. It's a odd, right? The multiplicity of 3 is odd or even?
Odd, sir.
Odd, right? So if you have a odd, then what will be doing? If you have an odd value, then it will cross. So if you are coming from plus infinity, okay, so at 3, the value should be 0, right? This is infinity, this is 0, because at 3, the value should be 0 because this is a root, right? This is a solution of the equation. So at 3, the solution, the function value should be 0. So it started with here, it started from minus infinity, sorry, plus infinity. It went to 0. Okay, at 3, because the function value at 3 is 0. Now you check the multiplicity of 3. That is odd. If we are getting odd, that means what? It will cross the line. So whatever this line is there, it will cross. Okay, and whenever the multiplicity is even, it will not cross. So whether it will just bounce back. So here you can see that at 3, you are having a odd multiplicity. So it crossed. So it came from here and crossed the line. And then it went to 1. It has to go to 0 because at 1 again, the function value is 0. Right? It went to here. And now you check for the y at 1, what is the multiplicity? At 1, the multiplicity is 2, right? And 2 is an even number. I told you for even number, it will bounce back. And it should bounce back. It's bounced back, right? And again, it went to -5 because the function value is 0 at -5. Okay, now you check the multiplicity at -5. And -5, again, it is an even number, so it should bounce back. It should not cross. So again, it will bounce back and it will go to -7. And now check for the -7. For -7, it is the multiplicity is odd. So it should it should cross the line. And it crossed the line, it went to the infinity. Is this clear to everyone or should I repeat it again? Just go through once again, just the plot. The multiplicity of 3 is what? 2. For 1, it is some even number. Sorry, it is odd number, right? It was odd number. It is even number. For -5, it is even. And for -7, it is odd. So whenever there is an odd, it will cross. So it started from here, -3, it crossed. 1 is even, so it reflects back. -5 is even, so it will reflect, like bounce back. And -7 is a odd, so it will just cross. Is it clear to everyone?
One doubt.
If you have been asked a polynomial, you'll be able to know that what is the root how many, like at minus infinity, what is the behavior of the function? And you will be asked, I'm telling you, will be asked in the exam also, this type of problem. Okay.
So one doubt. So I understood the graph part and also the root part. Can you explain how we arrived at the multiplicity thing? I haven't gone through the videos.
Okay, so the multiplicity is simply, you know what is multiplicity, right? How many repeated root are there? At -5, you can see that there are 2 repeated root, right? Because the power is 2, right? If you have an equation, generally in this, maybe in the class 10 you would have read, if you have x minus 2 ka whole square, then you have a 2 as a root, right? 2 as a repeated root, 2, 2. Correct? So this is multiplicity generally. So add minus, so you just, if you are not able to understand, you can just see that the number of counts that you have. At -5, what is the number of count? So if you'll write it like this, x plus 5 and then x plus 5, correct? So this is a one root, this is the other root. So -5, -5. So -5 ka multiplicity is 2. Similarly, you can write for all the other cases. Okay.
Got it, sir. Got it. Thank you.
Okay, and so the behavior you already know. If it's a even, it will bounce back. It's odd, it will cross.
Yes, sir. Yes. Sir.
Okay, so is clear to everyone? Shall I move to the next week content?
So I had one doubt. How did we get x to the power 8?
Okay, x to the power 8, we got it from here. So you have like x square is here, x is here, x square is here, x cube here. If you will multiply all these things, you'll be getting something x to the power 8 with some value, some coefficient. Correct? If you have, let's for example, x minus 2 ka whole square and then x minus 5 ka whole cube. So you'll be getting something x5, right? In the starting, and then the other function will be there that we are not caring about. Just the first thing, so that to get an idea about the behavior. Okay. Yeah.
Got
So,
it. Thank you so much.
So one more doubt, sorry. Why are we focusing on the infinity thing?
Yeah, we are just focusing on infinity. We are just checking how it is behaving at minus infinity and plus infinity, because we already know that if you are having the root, right? If you have the root, that means from whatever the value, if it starts with, let's for example, y equals to x cube. Okay, so at x equals to minus infinity, what should be the value? Y equals to minus infinity, right? At x equals to infinity, y equals to what? Infinity, right? So if you are plotting this function and you already know that x cube has a 0 as a root, right? Correct? X has what? 0 as a root only. At x equals to 0, your function will be 0. So it will start with what? It will start with at x equals to minus infinity. Let's, for example, this is minus infinity for x coordinate, and this is plus infinity. So it will start with some minus infinity, right? It will start with somewhere here, because y ka minus infinity is here, right? And it will go till plus infinity. It will go till plus infinity, right? And it should be crossing the line at x equals to 0, because it is odd, right? It will crossing, so it will go like this. Correct? This is the plot that you get from y equals to x. Right? Okay. Let's move to the next part. So the next thing is actually, this I already told you, for a 1-1 function, what should be doing is you have a horizontal test. Okay, if you are doing that horizontal test, it's not passing, like if it's passing for more than 1 point, then it's not a 1-1 function. If, let's for example, this function, it's a 1-1 function, because if you are plotting a horizontal line, it's crossing just this, the function at 1 point only, then it's a 1-1 function. Okay, and you can check it with the strictly increasing and decreasing also, that I told you, that if you have a function, a strictly increasing function, that means what? If you have two values, x2 and x1, at x2, if x2 is greater than x1, the function value should be greater than x, that the function value at x2 should be greater than x1. Okay, this is how the strictly increasing will be saying. For the decreasing function, for x2 greater than x1, you will be having the function value as x1 greater than x2. Okay. So this was so it's pretty simple. This increasing function is like it should be increasing. If you are increasing the value as the x value is increasing, the y value should increase. Okay, like this. Correct? And for the decreasing, it should decrease. If you are increasing x, let's for example, this is x1 and this is x2. If you are increasing x2, right? But the value function value is decreasing. This is a decreasing function. That is a 1-1 also. Because if you are if you are able to know that it's a strictly increasing and decreasing, you can directly say it's a 1-1 function. Okay. And this is also important. So to check so everything has been written in the notes. I don't know how will you get this notes, but okay, if you have something like I can upload these notes, you can just read it. Okay. And everything is there. All the important aspects have been written here. Okay, only you have to practice some questions from whatever the problem set that you have got. If you have a doubt, you can just mail me anytime. Okay, to check one function, and so either of the two, whether it's strictly increasing or strictly decreasing, either of the two, if it's happening, it's a one function. Okay, let's come to the exponential function now. Whether it's an exponential, okay, tell me exponential function is a 1 or not?
Yes, sir.
Yes, sir.
Yeah,
Yes,
you
sir,
can
it's a 1, 1.
right. Yeah, it's passing your horizontal test. Okay, so the behavior again, you can, if you have to plot a y equals to ax, now you don't have any, so like you at x equals to infinity, y equals to, at x equals to minus plus infinity, y is tends to infinity, right? So at x equals to, so y x equals to infinity, y is also infinity, right? And x equals to minus infinity, the y value will tend to 0, right? So it will be 0. So you can plot directly. Okay, this is simple, right? This is a plot, and if you will pass the horizontal, it's an increasing function also, and you can see that it's passing the horizontal test also. It's a 1 function. Correct? And similarly, you can do for the y to ax where a is less than 1. Okay, and this plot will be like this. Okay, is this function okay? Can you tell me? Everybody is convinced with this plot. If you have y equals to some 1/2x. Is it decreasing or increasing function? First, tell me this.
Decreasing, sir.
Strictly decreasing. Okay.
Decreasing.
Okay. So the plot is, you are able to understand how the plot came like this. If you are putting y equals to what did I say? Just put it x equals to minus infinity. If you are putting x equals to minus infinity, what are the value you will be getting? If you are putting here minus infinity, 1/2 minus infinity, that means what? It is equals to 2 to the power infinity, right? 2 to the power infinity is what? Infinity. Correct? So if you are putting x equals to minus infinity, why you are getting infinity? So if you are putting x equals to minus infinity, it starts with here. If you are putting x equals to infinity, if you are putting 1/2 to the power infinity, what is the value you will be getting? Why? If you have something 1/2, if you are multiplying 1/2 again, so the value is decreasing, right? This is 1/4. And if you are multiplying 1/2 infinite number of times, that will what? It will tend to 0, correct or not?
10 to 0.
So it will tend to 0. Therefore, if your x tends to plus infinity, the y will tend to 0. This is how you plot the any function. Okay, and this is 1 or not?
Yes, sir, it is
1, 1.
Okay. Yeah, I'll share this. If you are not able to get, I'll just in the end, I'll just share it on the some drive, my drive, and then I'll share it with you. Okay, that will be my personal, not the this IIT account and all. That's be my personal email ID, and I'll share with you. Okay, so just bear with me for some more time, half an hour, and then I'll share. Okay, and this is one of the important what you can say, the most important concept that from the week 5. Expected, you can just mark infinite star here. You can be given a function f, you can be given a function g, and then you'll be asked to calculate the domain of that function. Okay, so if you have a function f, you have a function g. Okay, so in the domain, whatever the value that are not there in the domain of gx, so the first thing is will not be there in the domain of f of g also. If let's for example x equals to 5 is not in the domain of gx, then in f of g also that x equals to 5 will not be there. Because if x equals to 5, at x equals to 5, if gx is not defined, how come that f of g will be defined? Okay, because it will be undefined. So how will you put any function like undefined value inside this function? Okay. So what is the first thing that you have got? That if some value is not belongs to the domain of gx, then it will not be belonging to the f of gx also. Correct or not?
Yes, sir.
Okay. And the second condition is for all x.
Can you repeat the previous condition which you said, sir?
Yeah. So I just told you, if you have some value x equals to 5, if that x at x equals to 5, if gx is not defined, okay, so that means what? X is not doesn't belong to the domain of gx. If x equals to 5 doesn't belong to the domain of gx, that means x equals to 5 will not belong to the domain of f of g also. Because at x equals to 5, if function gx is undefined, how can you put an undefined value inside a function of f? You can't put, right? That's why whatever the value which are not inside the domain of gx, that you should be excluding from the domain of f of g also. Is it clear?
Yes.
Yes, sir.
Yes, sir.
Okay. I'll give you one example.
Yes, sir.
Maybe that will help you. If you have a function, yeah, I told you this is a function. Okay, so second statement also I'll give you, and then I'll ask you to solve this. Okay, and the second equation is for all the value of x, where, see, there will be two conditions, right? One condition we have already fulfilled. That means all the values of x which is not under the domain of gx and not be under the domain of f of g. But there should be some conditions for f also, right? For f, what is the condition? For all x such that, let's for example, at x equals to, that's for example I'm giving, so this you should be hearing carefully. At x equals to, I'm giving one example, x equals to 1, function f of 1 is not defined. It's not defined. That means what? X equals to 1 is not under the domain of f1. Correct? That means f of g is what? If you are equating both the equation, that means what? This gx is equals to 1. So for all the value of x where the gx is equals to 1, those values will not be included in f of g of x. I'll repeat it. For all the value of x where gx is not, so gx ka value that you are getting. So if you are putting some value x ka value x equals to 1, and at x, if you are putting some value of x equals to 1, and then g of x, whatever the value you are getting, so g of x, so g of 1 you will be getting something, g of 1 you are getting something. Okay, and you are getting x, g of 1 is 2, and that 2 is not in the domain of function. That 2 value is not in the domain of function fx. That means you can't put this 2 inside this function, right? Domain is what? If you have f of 2 is not defined. Let's for example, f of 2 is not defined. That means you should not be putting any value of x, all the values of x where x equals to 2. Okay, so you should be excluding all the values of x where the gx is equals to 2. Is it clear? Did you understand that, the second point? Or you got confused? Okay, let's solve this example, then you'll be able to understand. This is the equation you have. Fx is equals to, and gx is equals to this. Okay, tell me, what are the values at which the function gx is not defined?
X equal to 0.
0, sir.
Okay, so x equals to 0 should not be there in the domain of f of g.
Yes, sir.
Correct?
Yes, sir.
So this will be some value, some set, excluding 0. Correct? Let's for example, this is r. So you can put all the values of r excluding 0. So this we got from the first condition. There is the other condition also that I told you. What was the condition? What was that condition? So at what point the function is, this fx is not defined?
X is equal to 1.
X equal to 1.
Huh. So will I write directly x equals to 1?
No, sir.
No.
G of X should not be 1.
You should be checking for which value of x. This
X
function
equal to 3.
gx equals to 1, right? Correct?
Yes,
Yes,
sir.
sir.
You need to check for all the values of x where gx is equals to 1, because this one you can't put inside this, right? You have a f of g function, right? F of g. If gx value for, let's for example, for gx some value, if gx equals to 1, and you already know that this you can't put, right? So you have to exclude all those values of x where gx equals to 1. Correct? Is it clear to everyone?
Yes, sir.
Yeah. So you should be excluding all those values of x where gx equals to 1. So if you are equating to 1, x equals to what? 3. So you should be excluding 3, not 1. Okay? Is it clear to everyone?
Yes.
Or should I
One
repeat
more
it?
example, sir.
What?
One more example, sir, please.
I don't have any other example, but okay, I'll just give you.
G of f of x. It is reverted.
Let me check if I have anything. Okay, let's do some random values. Just put it. And okay, if we have some function, if I will put giving. Okay, so let's delete this. Just change x equals x minus 5, 2x minus 5. Two x minus 1. Okay, the same example, but I change the value. Now tell me the values. Then I'll change it x minus 1. Okay. So from the first condition, what should we exclude from the first condition? The first condition was what?
1, sir.
Okay, you should be excluding 1. So at what point gx is not defined? So the first thing is at what point gx is not defined. So at x equals to 1. So this should be excluded because this also will not come inside this. Okay. But the second condition, at what point? So the gf. So what is the point that is not inside the domain of the function fx? X
1
equals
by 2.
1 by 2.
1 by 2, sir.
Okay. So you should be excluding all those values of x where the gx is equals to 1 by 2. Because if you are putting the f of g, that means you are putting some g value, right? And that g value should not be equals to 1 by 2. So that you should be excluding. That means x minus 1 equals to 1 by 2. So you will be taking x minus 1 equals to 6. So x equals to 7. So this also you should be excluding, right? So r minus 1 minus 7. Is it clear to you?
Got it, sir.
Okay. So let's move to the next part, logarithm. And I tell you, from logarithm, you'll be getting the questions on the basis of properties. So you should be knowing all the properties of the logarithm. Okay, the plot and all is fine, but you should be knowing the basic properties of the logarithm. Okay, everybody is aware of the basic properties of logarithm, right? This is the simple properties of the logarithm. Okay, 4 or 5 properties you have. Then you can get a problem like this. How many solutions this equation have? Can you solve it for me? Can you solve this equation? How will you solve? Can somebody tell me how will you approach this problem? And I am telling you, just mark it as star. So if you are getting a similar type of problem, just solve it out. Okay, you'll be getting this type of problem. Solve it. How will you approach? How will you start?
So instead of 9, we can write 3 square.
3x, you can write it something like t, correct?
Yes, sir.
Okay, then this 9x will be what? T square minus 2 into 3 into t minus 27 equals to 0, correct? You have to calculate the number of solution, Okay, just solve this equation. What are the value you are getting from t? Just solve it. What are the value you are getting?
9 and minus 3.
Okay, 9 and minus 3. Okay, then tell me the number of solution that you got. What is the number of solution for this equation? Can you directly write that 9 and minus 3 is the solution of this equation?
No, sir. 3 power x equals to 9 and 3 power x
Yeah,
equals
3 to the power x equals to 9. And then 3 to the power x equals to minus 3. So from here, what is the value of x you are getting?
2, sir.
And from here? What is the value of x we are getting from here? I told you,
So
na,
not
if you are
defined.
plotting, yeah, it's not depend because you can't get any value of x where the value will be negative. You already know that plot. What is the plot of x? You already know that, right? At x equals to infinity, what is the value of y? It will be infinity, right? It will be infinity. At x equals to minus infinity, y equals to minus 0. It will be 0. So it will go like this. So it can't be negative. So the value of x can't, there can't be any value where the function will be negative. Okay. So how many number of solution you have? Number of solution for this equation?
1, sir.
Okay, this is 1. Okay, yeah, correct. So this is a problem you should be expecting in the exam from this logarithm function. So I'm telling you all the important concepts and the problem that you can get in the exam. Okay, the similar type of problem should be solving from wherever you are getting, you just solve it out. Okay. Now the most important things, you should be getting some good portion like 2-3 questions from the graph theory. Okay, and this is important one. So you should be knowing this graph theory. Okay, I'm telling you 2 to 3 concepts and you should be practicing this 2 to 3 concept itself. Okay, and if you are able to practice this all, you are well and good. Okay, and you will be able to solve all the problems from paper also. Okay, that's why I just noted out all the important concepts that should be knowing. Okay.
Sir, I have a doubt.
Okay, go ahead. Yeah, go ahead.
Sir, as section B is not covered, sir, calculus. Can you tell us for calculus also, sir? Differentiability, integration, and calculus, sir.
That will be done tomorrow, the 24th, I guess. There's another session on the 24th.
Okay, sir. Thank you.
Yeah.
Sir, I have a doubt.
Yeah, go ahead.
Sir, how many question will we expect from calculus? Like how much percentage?
Maybe next session I'll be in the better position to tell you. Okay.
Okay, sir.
Percentage weightage happens. Not sure the weightage, but I can tell you for the graph theory you have some 3-4 questions. Okay? And this from each of the week you have some 1 questions, I guess, each.
And sir, total how many question we will get in qualifier exam in maths?
It is some 12-13 question, but will be in the form of some subparts. Okay.
Okay, sir.
So, okay. So what basically is a graph theory? What generally you know about the graph? If you have some relation A to B, how can you represent it in a graph? So graph theory is basically the mathematical representation. Okay, it's nothing new in this. If you have a relation from A to B, it can be any relation. Okay, let's for example, there's a station. There's A is a station. Let's for example, there's a Delhi and this is a Hyderabad. If there's a direct train, then you can mark it as okay. So this is how the relation like can be anything. So I just mark it as A to B is the train correlation. Okay, from A to B, I have a direct station. Okay, and I have a let's for example C as a station. From B, this Hyderabad to this Chennai, I have a direct train, but I can't find any train between A to C. So it will be like A to B and B to C. That is how you can plot the graph of any. Let's for example, A you just denoted as a station, Delhi, B as a Hyderabad, and C as a Chennai. Okay, if you have to reach from A to C, you can't go directly because there is no direct station. Because there is no direct relation from A to B, A to C. You can go via A to B and B to C here. Okay, like a simple. So you can represent many. So with the help of graph, you can just solve many other problems. Okay. So in the simple graph, how will it generally represent? The simple graph is like pretty like the way I represented. Okay. Simple graph doesn't have any self loop. That's for example, if you have A to B, B to C, something like this, it doesn't have this self loop. Okay, this is how the simple graph is just will not be including self loop anywhere. Okay. And the directed is like A is related to B. So let's for example, there's this A, B, C is some what you can say airport. Okay, Delhi, Chennai, Hyderabad. Okay, so you have a direct airport from Delhi to Hyderabad. There is so directed means from you can go from A to B directly, but you can't go from B to A. There is no flight directly from B to A. This is how you represent for the directed. And undirected is like pretty simple. It's like it can go from A to B and B to A. Okay, so A to B is related and B to A is also related. So you can go from A to B also and B to A also. Okay, this is how the undirected graph is. And the complete graph is like you can like let's for example this A B C. So it's like connected. Okay, this is a complete graph. But the important thing is from here it will start. Okay. Okay, adjacency matrix is there. Okay, so first I'll discuss the adjacency matrix and then I'll go ahead. Okay, but so in a graph, basically, many of you would not have read about the graph. Like if you have a graph, mostly it will represent in the form of V and E. V is generally the vertices that you have, and E is the edge. Okay, let's for example, for 3, you have for V, you will be representing something like this. You have how many vertices? 3 vertices, correct? And 3 edges, right? So it will be represented in the form of VE, where V represent the number of vertices that you have and then E. Okay, or maybe the vertices that you have A, B, C, and then the edges A, B, B, C, C, A. Okay. Okay, and then the important thing starts from here. How will you, if you have been given a graph, how will you write the adjacency matrix? Okay, and from the adjacency matrix, and this is important. This is very important. You can be given adjacency matrix and then you'll be asked how many number of vertices you have, how many edges are you having, how can you plot the graph from this adjacency matrix? Okay. Okay, and the most important thing, if you have adjacency matrix that is symmetrical about the principal diagonal axis, then you can directly say that it is an undirected graph, because A to B is related, then B to A is also available. That means if this is a symmetric, that means it's a undirected graph. You can be given the adjacency matrix and then can be asked whether it's a graph or undirected or directed plot. Okay. So you can say directly that it's a symmetric about 0, 0, 0, 0. You can say that okay, A to B is related, then B to A is also related. If A to C is related, then C to A is also related. That means it's an undirected graph. It's an undirected graph. Correct? Is it clear to everyone the adjacency matrix?
Yes, sir.
Please repeat, sir.
Sir, I have a doubt.
Go ahead.
Sir, apart from that undirected graph, can we define any other graph from the adjacency matrix?
Yeah, you can define the directed also. If this, see, directed, let's for example, you can have a directed graph. Okay, and then for that also you can know the adjacency matrix. See, I was telling from this is undirected because you are having a symmetrical about this principal gum. So this is a symmetrical matrix. Okay, that's why it's undirected. If it is not symmetrical, that means what? If you just remove it, let's for example, you have some connection A to B. Okay, and this is a connection B to C. That means how will you represent in the adjacency matrix? You'll represent something. So see, adjacency matrix, you write like this: A, this is B, and this is C. This is A, this is B, and this is C. Wherever there is a relation from A to B, there is a relation. So you will writing A to B 1, B to C is 1. Other than that, you don't have any relation. So you can just write it as 0, 0, 0, 0, 0. This is 0, 0. So this is what this is a plot of directed graph. Okay, and if this was undirected, that means A, B, and B, C. You can reach it from A to B, also B to A. So you'll be writing, you'll be just putting B to A also as 1, and B to C also as 1. C to what is that? C to B. C to B is also as 1. So this is what symmetrical, right? This is 0, I guess. B to C, where is that B to C? This is 1. So you can see that this is symmetrical about this. If it's a symmetrical, this is a plot of undirected. If it's not, you can say that it's a directed one. Got it or not?
Got it, sir.
Okay. So tell me, for this adjacency matrix, is it a undirected or directed?
Undirected.
Okay. And what is the number of vertices and the number of edges? Can you tell me the number of vertices and number of edges?
4 vertices, sir.
And how many edges? Just count it down. 1, 2, 3, 4. Correct? So 4 edges. But you can plot it if you are getting confusing. If you are able now to not get it. So what is the relation that you have? A to B is the relation. So A, B, C, D. You have a relation A to B, A to B, A to C also, A to C. Then B to A also you have a, okay, this is, we have already written B to D. So this is B to D. And then you have DA, DB, DB is also there, DC is there. You can see that 4 edges are there. Correct? So if you have been given in the exam adjacency matrix and then count, you've been asked for the vertices, number of vertices and number of edges, you'll be able to do, right? You'll be able to calculate, correct or not?
Yes, sir.
Yes, sir.
Okay. So that's the same matrix we have done. The vertex cover. So let's, for example, you have a graph with V vertices and E edges. So a vertex cover is a set of vertices that is a subset of your vertices original. So you have a graph. You have a vertices V. You have a vertices 4 vertices A, B, C, D. So V dash will be such that will be a subset of V, such that each edge in E is incident to at least one vertices in V. Did you get anything from there, the statement? Okay. See, if we have a vertices, let's for example, we have, okay, so just see this. This is a graph. Is it a undirected or directed graph?
Directed, sir.
Okay. So can you tell me the vertices cover? So, okay, vertices cover means for any vertices, let's for example, vertices 3. What it will cover? It will be covering this edge, right? It will covering this edge, correct? So vertices cover is like, so all those vertices, the list number of vertices, so that it will cover all the points. Okay, because that will be a subset of original vertices, correct? Let's for example, for this, can you tell me the minimum size vertices that cover all the Z? So just tell me, let's for example, 3 is covering 2 and 5, correct? So this is covered, this is covered, this is covered. Similarly, you can take 2, that will cover this, all this covered, and that will cover this also. So can you tell me the minimum vertices size? So which of the 2 or 3 or 4 vertices that will be taking such that it will cover all the graph, the edges of all the graph? Can somebody tell me? So you just have to take out the all those vertices. Okay, 5. So 5 will cover this. Then, but you have a
And then
remaining,
6,
right?
sir.
Then
4, sir. 4, sir.
no. It can have a multiple. Like you have to just, you'll be having some 2, 3 numbers. Then only you will be able to cover all this. You can't
2,
cover with
4,
1
5.
for sure.
2, 4, 5.
2, 4.
Yeah. So 5 we have covered. Okay. So 2. If you are putting 2, so it will cover this. It will cover this. It will cover this. It will cover this. Okay. Now you can take one more.
Yes.
4 you will be taking. If you are taking 4, that means it will cover this. So everything is been covered, right? So 2, 4, 5 is a minimum size vertex cover for G. This matrix is. Okay. Did you understand the? So the vertices that will cover all your edges. Okay. You got with the example, huh? So similarly, you can be asked what is the minimum number of vertices. The minimum number of vertices was 3, right? For this example, correct? That will cover all your graph, whole graph. So this type of example, see, and how will you use? So this, see, let's for example, in the you have to, you are working in some, you are a manager in some hotel or somewhere. So this is the shape of your hotel, okay, and then some shape or something is there, like some hotel or something you can imagine, and then this is like 1, 2, 3 is the portion where you are want to put the cameras. Okay, so how many minimum number of cameras that you'll be needing so that it will cover whole places. This is a balcony, simple balcony you can think of. Okay, so you'll be putting, you can just, if you are putting the camera at 2, 4, 5, you'll be able to cover all your hotel. So if somebody is like, it's not that if he's not optimizing the cost, this is the optimized cost, right? You are just putting 3 cameras, it will cover all those hotel. If you're putting all the camera from 1, 2, 3 everywhere, it's like, it's not, you're not optimizing the cost. So if you're putting 5 to 4, like camera at 5 to 4 only, it will be covering all those stuffs, right? So it's basically helping that, like this type of problem can help you in those, what do you say? It basically help in those type of problems. Got it, right? Let's come to the most important thing. So you'll be expected to know that You are just expected to know this all stuffs only. What is graph theory? What is vertices cover? If you have been given the plot like this, will you be able to cover, like, know the minimum size vertices that will cover each edges? And then if from the adjacency matrix, whether you are able to calculate the number of vertices, number of edges and all or not. And then your last and then final topic of today's session is the spanning tree. Okay, so as it is a spanning tree, you should not be having any closed loop. So a spanning tree is simply you have a graph and then you have been asked to know the spanning tree of that. So from the given graph, you have to know about the spanning tree. As it is a tree, it should not be closed. Okay, so the first definition, the first property is that a connected subgraph of whatever the graph you were having the starting. So you have some graph and then you have been asked to plot the spanning tree. So that should not be so. And see, you should be taking all the vertices, but you should be having the edges n number of n minus one n minus one edges should be there. Okay, in that spanning tree that will be calculating. As it is a tree, so it should not be any. You should not be having any cycle. Okay, and what does that connected subgraph mean? See, I'm just explaining once again. You have a graph. You are needing a spanning tree. That means you are needing a subgraph from that graph, and that subgraph should be connected to each other. So you should be able to reach from any point to any point in that graph. Let's, for example, you have ABCD as a graph. Okay, what can be the spanning tree? Will this ABCD will be spanning tree? I told you some important properties of spanning tree. It should not be closed. If in the option, if it is given that some closed form, you can directly remove that. The number of vertices will be 4, the same, but the number of edges will be n minus 1. So if you have any options, you have more than n minus 1 edges, you can just remove them. Okay, so can this be a spanning tree for this graph? This is your graph. Is this a subgraph? Is this a subgraph so that you can reach from any point to anywhere in this graph, in this spanning tree? Is this a spanning tree or not?
Yes.
Yes, sir.
This is a spanning tree, right? The second option, is this spanning tree? Can you reach from A to D here?
No.
If you can't reach, that means what? See,
It's
here
not a
the
spanning
other
tree.
condition was satisfied. 4 vertices is there, 3 edges are there. Okay, fine. But the other thing is what? So there are 3 basically properties. It should not form no cycle should be there. N minus 1 vertices should be there. All n minus 1 edges should be there. All vertices should be there and it should be connected. Connected means you can reach from any station to anywhere. Okay, any station means I'm just giving you an example. That means from A to anywhere you should be reaching. Is this third spanning tree? The third one?
Yes.
Yes, sir.
Yes, sir.
Okay, because 4 vertices correct, 3 edges correct, no cycle correct, and then can you reach from anywhere? Okay, to anywhere. Okay, correct. Similarly, this can be also a spanning tree. This can also be a spanning tree.
Yes, sir.
Okay.
Yes.
Yeah. And the last thing is minimum spanning tree. So there are like 2-3 algorithm. I'll just give you basic, simple algorithm. Okay, I'll not name that also. Just if you have been asked in the exam, just solve with this method. And you'll be able to calculate that. Okay. So you can have a lot of minimum. You can have a lot of spanning tree. Okay. See, you can. So you have seen that there are a lot of spanning tree. But if you have a weight, let's for example, if you are having some weight means if you have some cost. Let's for example, if you have to go from A to C, there is some cost, 8 rupees to go from A to C, and there is some cost, right? Okay, and if you have a function like for A to C, if you have to go, and if this is costing 5 rupees and this is costing 10 rupees, why will you go by this way? This is B. We'll be going directly, right? Or let's for example, this is A, this is C, and this is B. Costing from A to reaching B is 2, and from B to C is 4, and directly from A to C is 10 rupees. Then why will you go directly? You'll be going A, B, C, right? So this is what the weight is. Weight is just reflecting some cost or something reflecting. Okay, and that weight you have to minimize. So you have to get the minimum spanning tree where the cost is minimum or the weight is minimum. Okay, what you'll do is you have a graph. So you just arrange the whatever the weight is there, you just arrange it in the forward like ascending order. Okay, just arrange it in the ascending order, Okay, I wrote it down here. Okay, and then what will I do? I'll start with 2. So wherever the 2 is, so this 2 I'll write it. So you already know that there should not be a circle. The vertices should be equal. So the vertices, I have taken all the vertices. There are like how many vertices? 4 plus 3, 7 vertices. I have taken all the 7. And there should be 6 edges. Okay, so I started with 2. So I took it 2. Then I went to 3 because 3 was the next number. So 3 can be here and here. So I can take any of the 2. So I just took it here, this one. Then again 3. So I took it this one. 4. So I took it this one. Similarly, if you are doing all those 4, so 4, you took it. The first one, the second 4 I have taken. So see, if the third, fourth, if you are taking, this is the third, fourth. If you will take it, what is the rule that is violating? If you are taking this 4 also, what is the rule that are violating? I told you some rules about the spanning tree.
Cycle.
Yeah, it will form a cycle. That should not be formed. So that's why we'll skip this 4. Okay, we'll move to the 5. So 5, where are 5? Here it is, here it is. If I'm taking this 5, it will again form a form, like it will again form a loop, or not loop, this cycle. So you should not be taking this 5. Again, you'll come with this 5. So you'll be marking this 5. Now you move to the 6. If you are moving to the 6, so it's already, you can see that you have like how many edges should be there? 6 edges. You reach the 6. 1, 2, 3, 4, 5, 6. That's it. Okay. So you should not be marking any 6. Even if you'll see that, if you'll mark C here, it will be a loop. Again, if you're marking here, okay, it will not be a loop. It will again a loop, right? So it'll be making a loop again. So just put it in the ascending order. Start with starting the minimum cost, and you can see that from anywhere you can go to anywhere. So all the 4 properties are applying. So what is the minimum cost? You can just add it. Okay, this is the 21 for this case. So you can reach it from any point to anywhere here. So and the 4 properties, we already know that vertices, the number of vertices should be 7, and it's 7. So the number of edges should be n minus 1. So 7 minus 1, that is 6. It's there. Okay, but a cycle it should not form. Okay, this is not forming the cycle. Okay, is this clear to everyone? The spanning tree, if you have been given the exam, you'll be able to calculate or not?
Yes, sir.
Sir, can you repeat why we are not taking from D to F?
Okay, D to F. I'm not taking D to F because it will also fall. If this will be a loop, right? This will be a circle, correct? The circle should not form. It should not form any circle.
Got it, sir.
Yeah. So yeah, so I just finished all the stuff that are important for your paper. Okay, just go revise all this stuff. Okay, if you are able to revise all this, I'm pretty sure you'll be able to solve most of the problem in the exam. That's why I just discussed all the important aspects that are important for exam. Okay. Just solve this stuff, all the problem from these topics. Okay, if you have not much time, like you have some 10-15 days. Okay, so just solve all those problems that I told you. At least first solve those and then go and solve the other portion. Okay.
Sir, one question: how many
So can you share
vertices?
this?
What?
How many vertices are 7? How 1, 2, 3?
No,
There
vertices
should be
are.
how much?
This is what is one vertices.
Yeah. So how many it should be for?
It should be n vertices. This whatever was there in the graph, it should be n vertices and n minus 1 edge.
Yeah. So how n is 7 in the graph? Okay.
You can see this is
1, 2,
1,
3, 4.
3,
Okay.
3, 4, 5,
Yes.
6, 7.
Understood.
Yeah.
Thank you, sir.
Okay. So should I upload this? I'll just stop sharing and then I'll upload it and then I'll send it to you. Okay.
Sir, you will share the link in the chat box.
Yeah,
right?
yeah. I'll just share it now itself. So I just stop sharing and then I'll just do it, upload it somewhere, and then I'll share this.
Yes, sir. We are waiting in the meeting only, sir. Then.
Yeah. I'm just doing it. Wait for a minute. So if you have any doubt or whatever I have discussed, you can ask me. You have some 2-3 minutes. You can just ask me. Otherwise, if you have any doubts while solving any problem, you can just mail me. I just told you my mail ID. That is, I'll just write it down also. That also I'll write it. So you have this file. Okay, new folder.
Sir, can you please refer any source to practice questions from?
No, same. So if you got the problems right from the ITM. Huh? Did you got the set of questions?
So we got a mock paper, yes.
Only one paper?
Yes, sir.
Okay, so previous term paper you can get it. Okay, you just Okay, in the same slide, I'll upload the papers, some papers. Okay, for the previous time, you can get an idea. Okay, in the same folder. So maybe you can just spread it out to the people who didn't attend the session. I'll just upload it maybe tomorrow. I'll get the previous paper and I'll upload it here. Okay.
Okay, sir.
So in the same slide, I'll just same folder. I'll upload the remaining questions. Maybe by tomorrow you can just refer that. And I'll upload it if you want. I can upload some questions also, but I'll have to see that. But okay, I'll try to upload some more questions. So when is the paper? When is that exam?
Third, sir.
3rd September.
Okay. Okay, so you can just check it whether you are able to open that or not. So just check it whether you are able to open that or not.
Yes, sir. You're able to open.
Okay.
Yes, sir, we cannot.
Okay, then
able to.
yeah. So we'll meet again, but till that, if I'll be taking, I'll meet again. Then otherwise, if some other people will come, I'll be taking the session. Okay, so
Sir,
if
can you
don't,
write your email ID also?
yeah,
Where
just write my email ID. Okay. My email ID, you can just ask me a doubt, whatever you have. Okay, like please don't spam anything. Okay, you can just ask me your doubts, whatever you have. Okay, if you don't have any doubt, I'll just close this session.
Sir,
Yeah.
there is a question in the sample paper which is related to graph. Can we discuss that if you have time?
You can just send me on my, I'll just forward the solution. Okay.
Okay. Okay.
Yeah. It's already
Thank you
9,
so much, sir.
10:30. Yeah. Okay. Thank you
Thank you,
everyone
you
for
so
joining the
much, sir.
session. Okay.
Thank you so much, sir.
Yeah. Thanks.
Thank you.
All the best for your
Thank you, sir.
exam. Okay.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.